Here we have a SAT math problem. Okay, let's go to the question. For the equation 6r x square positive 60 sx positive 6r equals to 0, what is the largest ratio of r over s for that to be at least one real solution? Here we have a quadratic equation, and for this quadratic equation there must be at least one real solution for which we have to find the largest ratio of r over s. Okay, now let me consider the quadratic equation standard form, that is ax square positive bx positive c equals to 0. So for this quadratic equation, if there is at least one real solution, then the value of the discriminant b square negative 4ac has to be greater than or equal to 0. Okay, comparing the given quadratic equation over here with ax square positive bx positive c equals to 0, we get a equals to 6r, that is the coefficient of x square. Here the coefficient of x square is 6r, and b equals to the coefficient of x, that is 60s. Let me write it over here. And the constant term c equals to 6r. Okay, since there must be at least one real solution for this quadratic equation, so the value of the discriminant b square negative 4ac must be greater than or equal to 0. And for this b, we can plug in 60s. Let me do it. 60s the whole square negative 4 times, and the value of a is 6r. We can plug in 6r for a, and for c also we have the same 6r. We can plug in 6r for c greater than or equal to 0. Okay, 60 the whole square. Here this negative, this 4 can be written as 2 square, and when we multiply 6r by itself, it can be written as 6r the whole square greater than or equal to 0. Then we get 60 the whole square negative. Here two terms are multiplied with the same exponent 2. Whenever two or more terms are multiplied with the same exponent, we can write the exponent in common. That is, we have to multiply the two bases. That is 2 times 6r the whole square greater than or equal to 0. Then we get 60s the whole square negative. When I multiply this 2 and 6r, I am getting 12r the whole square greater than or equal to 0. Okay, now let me erase the stuff over here and continue the problem. Okay, now let me consider the algebraic identity, that is the difference of two squares, that is a square negative b square. Whenever we have difference of two squares in this form, it can be written in the factor form, that is a positive b times a negative b. Consider the expression we have over here. It is exactly in this form, a square negative b square. At the place of a, we have 60s. At the place of b, we have 12r. So we can write this one in factor form, that is like a positive b times a negative b. So for that, we have to write 60s at the place of a and 12r at the place of b. Let me complete it. 60s negative 12r greater than or equal to 0. Okay, here consider the terms of the expression we have over here. So both 60 and 12 have the greatest common divisor 12. So we can factor 12 out. But I am going to factor 12s out from this expression. This 12s. Why do I factor 12s out? Because I want to get the stuff r over s. So when I factor 12s out from this expression, I'll be getting this stuff r over s inside the parenthesis. Okay, when 12s is factored out from this expression, to get the stuff inside the parenthesis, we have to divide the terms of this expression by the one I factored, that is 12s. Okay, now to get the first term, we have to divide this 60s by this 12s. Let me do it. 60s by 12s. This yes will cancel out. When I divide this 60 by 12, I'm getting 5. So when 12 is factored out, then in the first term, we are left with just 5. Okay, now to know the stuff which are left with the second term, we have to divide this 12r by this 12s. So when I divide this 12r by 12s, this 12 will cancel out. We get r over s. So we are left with r over s. Okay, the same thing we can do over here in this expression. That is, we can factor 12s out. When 12s is factored, then we get 5 negative r over s inside the parenthesis over here, greater than or equal to 0. Okay, now we can multiply this 12s and 12s. Then we are getting 12s the whole square times 5 positive r over s times 5 negative r over s greater than or equal to 0. Now let me divide both sides of this equation by 12s the whole square. Let me do it. 12s the whole square. When I do so, this 12s whole square will cancel out. I am getting 5 positive r over s times 5 negative r over s greater than or equal to 0 divided by anything is still 0. Okay, now this is the resulting inequality I am getting. Okay, now let me erase the stuff and continue the problem. This is the inequality, we got it in our previous work. Okay, now what I am going to do is I am going to consider this inequality as an equation and solve for r over s. Okay, now let me say that phi positive r over s times phi negative r over s is equal to 0. Okay, here the product of two binomials is equal to 0. Whenever the product of two quantities is equal to 0, the first one may be 0 or the second one may be 0 or both of them may be 0. If the first one is equal to 0, then we get phi positive r over s equals to 0. Or the second one may be 0, that is phi negative r over s equals to 0. Okay, now let me subtract phi from both sides. When I do so, this positive phi, negative phi will cancel out. Then we get r over s equals to negative phi. Okay, here let me subtract phi from both sides. That is the same thing. So here positive phi, negative phi will cancel out. I'm getting negative r over s equals to negative phi. Okay, now to get rid of this negative sign over here, I multiply both sides of this equation by negative 1. When I do so, this negative times negative will become positive. Then we get 1 times r over s as r over s. On the right side, when I multiply negative 1 and negative phi, I'm getting positive phi. Okay, I'm getting two values for r over s. One is negative phi and the other one is positive phi. Okay, now let me mark these values on the number line, negative phi and here positive phi. On the left side extreme, we have negative infinity, and the right side extreme, we have positive infinity. Okay, now we can split up the number line into three intervals using the two values we got for r over s. So the first interval is negative infinity, comma negative phi. Let me take square bracket. Then the second interval is negative phi, comma positive phi. Let me take the square bracket. And the third interval is phi, comma positive infinity. Here I'm taking square bracket along with the numbers negative phi and positive phi, because in the inequality we have here, we have greater than or equal to. So if we have just greater than, then we have to use parenthesis. That means this negative phi and positive phi will not be included. But here we have greater than or equal to, so we can include these two values, negative phi and positive phi. That's why I'm using square brackets over here. Okay, now what I'm going to do is I'm going to check each of these three intervals with the inequality over here, and I have to find out the one so which satisfies the inequality over here. Okay, now let me take the first interval. The first interval, let's take a random value. I think we can take negative 6 over here. Okay, now let's plug in negative 6 for r over s in this inequality, because here we got this interval of values for r over s. Okay, when I take a negative 6, a random value in the first interval, and when I plug in negative 6 for r over s in this inequality, what will happen? Let me see, phi positive, and we have to plug in negative 6 for this r over s, that is negative 6 times phi negative of negative 6 greater than or equal to 0. Okay, here phi positive times negative is phi negative 6, and here phi negative times negative will be positive 6 greater than or equal to 0. Phi negative 6 is negative 1, and phi positive 6 is 11 greater than or equal to 0. Negative 1 times 11 is negative 11 greater than or equal to 0. Actually, this false, because any negative number can never be greater than or equal to 0. So this is false. That is the first interval, negative infinity, comma negative phi, does not satisfy the inequality, so we can reject this one. Okay, now let's verify the second interval. So let's take a random value in the second interval. Clearly it's 0 between negative value and positive value. We find 0. Let's plug in 0 for r over s in this inequality. In that case, I'm getting phi positive 0 times of phi negative 0 greater than or equal to 0. So phi positive 0 is phi, and phi negative 0 also is phi greater than or equal to 0. Then we get 25 greater than or equal to 0. This is true. So the interval negative phi, comma positive phi satisfies this inequality over here. Okay, anyways, we can verify the third interval as well. That is phi, comma positive infinity. Now let's take a random value in this interval. That is 6. So when I plug in 6 for r over s in this inequality, let's see what's happening. Then we get phi positive 6 times phi negative 6 greater than or equal to 0. So this is 11, and this is negative 1 greater than or equal to 0. 11 times negative 1 is negative 11 greater than or equal to 0. So again it's false, because a negative number cannot be greater than or equal to 0. So the third interval, phi, comma positive infinity, does not satisfy the inequality we have over here. So only the second interval, negative phi, comma positive phi, satisfies this inequality. That is, the value of r over s can be any value from negative phi to positive phi. Let me write over here. Negative phi less than or equal to r over s less than or equal to positive phi. Okay, clearly the maximum value of r over s is phi. So that is the largest ratio of r over s is phi.